So I'm Vashan Wright. I'm a professor at Scripps Institute of Oceanography at University of California, San Diego. And in general, I study landslides, earthquakes, and on Mars, I study the hydrological cycle. Where is water? Is there water on Mars? How has the planet evolved? InSight collected data about how the ground is moving on Mars. Particularly of interest was how the ground moves after there's a Mars quake, which is kind of the same as an earthquake, but it's on a different planet, Mars, or how impacts hit the planet and then how the ground shakes. And a lot of the current work is centered on analyzing the data that InSight collected during its uh, lifespan or when it was operating. So many people are doing that right now. They're looking at the data and saying, what does that tell us about the subsurface of Mars beneath the surface of the Earth? What does it tell us about how the planet has evolved through time? What does it tell us about whether there is water? And if there's water, how much? Is it in liquid form? Is it in icy form, etc.? In terms of Mars quakes, when those quakes happen, the waves travel and they travel at different speeds depending on what type of material the waves are traveling through. And so, if you have a rock that is harder, there's more stuff in there, the waves are going to travel faster. If you have a rock that's a little bit softer, there's less stuff in there, the waves going to travel a little bit slower. If you take that hard rock and you put some water in there, in the cracks in that rock, it's going to even travel a little faster. If you put ice in there, ice is going to make it travel faster. Ice in the cracks is going to make it travel faster than water in the cracks. And so essentially, it's really about how the speed of those waves change. And we take all of that and say, okay, is this speed of the wave more consistent with a dry Martian crust or a liquid water filled Martian crust based on what we know about some things in the planet? And it seemed like it was more consistent with liquid water and crust. If there's water beneath the surface, it would be very difficult to get that water. You know, on Earth, what we do is when we drill, we circulate some mud, some fluids to make the drilling process easier. Because when you put water, mud, you can drill through a rock easier. Um, uh, and So you'd have to bring that to Mars. The other thing is that we need power to do the drilling, and so there has to be power as well on Mars. So that those are the complications for drilling. Um, it might be easier to get the ice that's closer to the surface because the water we're talking about is at roughly 10 to 20 kilometers beneath the surface of Mars. And so getting ice near the surface might be easier and then melting it. So Mars once had water on its surface in forms of liquid, in forms of oceans, rivers, lakes, etc. And one of the question is, why does it no longer have water on its surface? The proposed answer is that it lost its atmosphere. It used to have an atmosphere. The atmosphere protects us from the sun's rays. When you lose the atmosphere, the sun is directly shining on the planet. There's no protection. So water can evaporate and go out of space, or water can go down into the rocks. And so a big question is, where did all that liquid water on the surface go? And we've always thought solutions were that it got lost to space, because the atmosphere is not keeping it on the planet, or it went underground. And liquid water is important for life as we know it. We don't know any life that doesn't require liquid water. And so that's one of the significance of this. It means that because on Earth, at deep depths where there is some source of energy, heat, and liquid water, we see exotic biological form of life, microbial life, deep. And it so life as we know it requires those things. And if Mars has liquid water, it means that it's potentially habitable down there for life. I think it began when I was in high school, and I realized that I didn't want to be a doctor like all my friends. It felt like every time I learned about a new disease, I thought I had it. And so I'm like, that doesn't sound like a good career to be in. And then I just thought about what did I like the most, which one of my teachers I liked the most, encouraged me the most, and that was geography. And so I kept asking the question, how can I do something that is in the processes that I learned in geography? What I loved in geography was mountains and coasts and plates moving past each other, and earthquake and volcanoes. And I kept saying, I like physics, I like outer space things. So I just really just followed my passion. And it's still an interesting question of what process led to Mars being what it is today, from something that looked a lot like Earth 3 billion years ago to something that no longer looks like Earth, is dry.